Hi guys, and welcome back to this series on Beginner's Guide to Air Navigation for Flight Simulators. Now, just a caveat, I am not a professional pilot. I don't work for an aviation organisation, so this is really just something I do for my hobby. So the information that I give you is not going to be 100% accurate, and probably the way I do certain things is not going to be absolutely correct, but hopefully I can get you interested in something that's probably one of the more interesting parts of flying a simulator. As I've said before, when you're flying a simulator across country, it's kind of pretty boring. The scenery is not usually very amazing, and so one of the more interesting parts is landing, taking off, and navigation. And in the last video, we looked at something called an NDB, or a non-directional beacon, which is really the kind of simplest of the radio navigation aids that we have available to us across the Earth. And today I want to talk a bit about something called distance measuring equipment, or DME. And there's a couple of uses for DME, but as maybe a next step up from using NDBs, it's quite a straightforward way of getting your bearings. And one thing you've got to remember is that when you're flying, you can't see the kind of lines that you see on the map. You don't see these sorts of things painted on the ground. There's all very well having dotted lines on the map, but because you can't see any of it, you have to be able to rely both on your eyes, but more importantly, in most crowded areas like the UK, where there are controlled traffic areas all over the place, you need to be aware of how to use your navigation instruments so that you don't stumble across accidentally into controlled airspace. If you do that without permission, obviously, as well as the risk of getting in trouble, you risk some kind of air collision or something else. So it's not something that you want to play around with. And here's one example of where distance measuring equipment might be useful, and we'll look at what it looks like and how we find it in a second. But imagine we are starting at Kemble Airfield and we're flying to Oxford Airport at Kidlington. We can see that right in between these two is this big massive Brize Norton, and it's basically an Air Force controlled zone, controlled traffic, CTR, whatever that is, controlled traffic something. And you can see here it's established from the surface to 3,500 feet. So although theoretically you could fly over it, if you were flying from Kemble to Oxford, you wouldn't really have a lot of time to get up to a particularly high altitude. So you risk running into this controlled traffic area, and without permission you're going to cause trouble. But the authorities in the UK recommend that if it makes sense to go through it, then plan the possibility that you can go through it by radioing and asking for permission. But obviously, if you're not given permission because it's a busy day, there's a load of stuff going on, whatever, then you also need to plan to go around it. Now, in this case, pretty much as soon as you take off, you would probably radio into Brize Norton radar, either the zone here or Brize Norton radar, which you can see the frequency just off the top here. And basically ask them for permission to transit this zone if that was the route you were taking. Now, at Oxford, they mainly use the north-facing runway to avoid Brize Norton, and they will only generally send you here if necessary. But, most cases you'll be flying in from the top. But let's imagine that you kind of want to go from here, you want to cut across the top. So as soon as you take off, you're going to radio them. But of course, what happens if you're taking off from a lot further away? How do you know when you're reaching Brize Norton? And as I mentioned before, you see these visual reference points. They're dotted all over the map. Farringdon, Lechlade, I think North Leach roundabout is up there somewhere. So they're kind of visual references to show you when you're kind of approaching the zone. But of course, you can't really take too many chances, because you only have to go a little bit into here to be in danger of having some kind of collision. So when you're traveling from much further away, what would be really useful would be to get a fix on this zone, or particularly an item within it, like this TACAN here or an NDB, in some way or other to tell you how far away this zone is. And then if you know from measuring off your map that that distance there is, let's say, 10 miles, for example, then you could basically work out that if I am 10 miles from the Takan, then I'm probably about to enter the territory. So if I had maybe another 10 miles to that, or 5 miles, depending on how fast you're going, you might say, right, when I'm 15 miles from this Takan, then I'm going to radio them to say, can I transit your controlled airspace or not? And if not, obviously you can work out how to go around. So that's probably the first and most obvious use of something which is going to use our distance measuring equipment. So let's just have a quick look. Yep, that one. At what DME looks like. So this is actually the symbol for a VOR, which we will look at in the next video, combined with distance measuring equipment. And the reason this symbol is so common is virtually every single VOR in the UK has distance measuring equipment. So the DME is the box and the VOR is the hexagon inside it. But there aren't any places other than terminals where you'll find DME that's not co-located with either a VOR, which we will look at, or something called a TACAN, which is a military version of a VOR. So they're kind of all to do with headings and being able to measure headings off of a beacon. That's why I'm going to do them a separate video. But almost all the time, this is a classic example. This is a Brixham VOR. And you'll see here there's a little box. It's pointing to the little symbol, which is this symbol. You can just about see it here on the picture. And it has a frequency, and it says the VOR is basically the big compass feathers that you can see here. And it has the letters DME. And like I say, every VOR that I can find, apart from two, there's one in Cranfield near Milton Keynes and one in Perth, that have a VOR like this without a DME, and they have a little hexagon symbol, but almost every single other one, and there are lots of VRs we'll see on the map in a second, will have distance measuring equipment. And that's significant because it's the frequency of the VOR that you will use to tune in to the DME. A second type of DME that you will see has a T at the beginning, and that just means it's a terminal DME. It's distance measuring equipment used for when arriving, sometimes when departing as an instrument approach or departure from an airport. So in this case it's Cardiff, and this DME is not so useful for navigating cross country, because it's not necessarily centered on anything useful. So okay, it could give you a rough distance to Cardiff Airport, which might be useful, but in most cases you want to fix to something like a VOR, which is a known position which you can navigate from. So this is generally lower power. It's going to transmit for a shorter distance, and we'll see in another video when we look at approach charts how the terminal DME is useful. And the one that we looked at just now as well is a TACAN, which is a military version of a VOR. Don't worry what those things mean, but every TACAN also incorporates DME. So although it doesn't say DME on here, if you tune into 111.9, you will get a distance off the TACAN, but you won't get bearing information unless you're flying a military airplane. So for most of the time, we'll be looking at VOR and we'll be tuning in. So here's a little picture of a DME. It's a fairly simple beast. We don't really care too much how it works. All we need to know is we tune into a frequency, and once we tune into a frequency, then the equipment does the rest. So let's pop over to X-Plane. So what I've just taken off from Shoreham Airport, which is just underneath me here. This is me in the middle of the map. And you can see that there are a lot of VORs within spitting distance of Shoreham. And that's because Shoreham is on the south coast and London is just here. And as you might imagine, there are lots of these beacons for lots of different types of approaches and departures from places like Heathrow and Gatwick. And I chose it just so I could find two VORs, both of which have distance measuring equipment very, very close to where my plane is, so I can make sure that it picks up two signals. And just let's pop out the GPS a second. Although we're not really bothered too much about the GPS, just to give you an idea, this VOR is called May, and you can see it's almost in front of me, slightly to the left. and then the other one, which is is it Beachy Head, SFD, can't remember, is over to the side. So this is basically a representation of how my plane sits in relation to these two VORs that also contain DMEs. Now they're shown on the GPS as something called a VORTAC, and that's kind of not the right symbol, so don't worry about those symbols, but that's probably just X-plane. But you can see here, this is me pointing towards May, and that one there is SFD. Now, if you see here, Mayfield, tells you what it's called, is 117.9 megahertz. You'll notice that I have my nav2 little box here tuned into 117.9. You can almost see it. I think if I click that, pop that across. So 117.9, and you can see that it's saying here that the distance is 70 miles and the bearing from where I am is 67 degrees. Now, because that's kind of in front of me, you can see that it's basically saying from 0, if I move around 67 degrees, that's where I'm pointing. Now, I'm not flying at 67 degrees, so in actual fact, that's slightly to the left of the direction that I'm heading in. But you can see that the equipment has automatically pulled out the distance, and it will be displayed in different places depending on which aircraft you're in. Obviously, some of the more basic ones won't have these kind of flight computer kind of modern things in, so they might just have a much more simple indicator. Now, if I pop out the kind of nav1 computer, the one that's got the GPS, you'll see that as it happens, if I click on this one, not on the aircraft, that's a bit annoying. If I can click around the can I click the VOR? No, thank you aircraft for getting away. If I click on SFD, there we go, you'll see that the frequency as it happens is quite close to the other frequency, and that's just kind of random. It's, you know, it's not a rule that VORs that are close together are close in frequency. That one happens to be 117, and if we pop this across, you'll see that my nav1 is tuned to 117. And something that's quite cool about this computer, this flight computer, let's just pop that back. You can see here that there's some slightly more information available on this little display than there is on nav2. So in this case, it's actually identified the VOR for me. Now, if it didn't do that, obviously I'd have to just double check and make sure that I'm pointing in the right place. And this RAD is short for radial, so it's saying in reference to SFD, I am flying, basically I'm not flying towards it, but if I drew a line 288 degrees out from this VOR here, this DME unit, that's where my plane is. So obviously as I'm flying up here, that's going to increase because I'm effectively moving around the circle. Whereas if I was flying directly towards it, then obviously that would stay at 288 because it's saying that I'm arriving at this VOR DME at an angle of 288. So the distance can be quite cool because, as you can see, I'm just going to unpause it and we're going to fly it just to show. Right, so this is SFD, so everything's probably going to go wrong now. But if I tune this out, I'm just going to turn as I'm climbing towards SFD because that's the one that's tuned in. You can see it's about 15 miles away, which sounds about right. And then you can see here, whoops, I think it's probably a bit windy today. As I fly towards it, you'll see that distance is obviously going to reduce as I get closer and closer. 15.5, 15.4. So as you can see, it's really useful. It's useful. Let's just pause that because that's probably not much use. It's useful because for a number of reasons. So the first of which we've already talked about, if this was the centre of a controlled traffic area of some description or even an aerodrome, and I need to know whether I'm about to enter it, well, that's useful. 15 miles. If this had a 10-mile radius, I know that I'm getting close. I need to radio the controlled traffic centre and ask them for permission to transit. If they say no, I need to go around. But another way of navigating is when we navigate in the next video, we'll go from VOR to VOR, which was a kind of a bit of an old school way of navigating before GPSs existed. Then we can also use that just to give us that kind of gut feeling of how far we've got to go, because you've got to remember that, you know, the more headings, the more readings that you can get, the more information that you can get as a pilot, the more sure that you can be that you're flying in the right direction. So if you had nothing else, if you had none of these computers and you just had your eyes, then obviously there's a lot of risk that you're going to go wrong. If you have one NDB, well, that's got an arrow, that's quite basic, but that might be quite good. If you have an NDB and distance measuring equipment, you know, you're starting to get more data points, you're starting to get more clues if you're going wrong, and you might go, hang on a second, I didn't think the airport was that far away. Why is it telling me I'm 100 miles away? Is it because I've tuned the radio wrong? Is it because I'm flying in the wrong direction? Have I tuned the NDB wrong? Etc, etc. So the more data points you can get, the more useful. So traveling VOR to VOR is also useful. A third use of distance measuring equipment is to be able to estimate how soon you need to start descending. So with a light aircraft, they tend to say it's about a mile for every 1,000 feet. So if you need to get down to 2,000 feet from 10,000 feet, you're going to need about 8 miles of distance. So depending on what you're measuring your distance to, if you're measuring it to a point on the approach to an airport, then that might be a good way to say, well, when I'm 8 miles out, I need to start descending at about 500 feet per minute, and then that should get me roughly to 2,000 feet by the time I arrive at whatever it is I'm aiming at. And then that's going to get me about the right kind of altitude to fly the pattern. So that's a third use of DME. And a fourth one, which we'll look at when we look at approaches, instrument approaches, is DME is very often used as a way of directing your approach to an airport. So it might say, fly this bearing. I mean, there's the map, show map. So an approach to Shoreham Airport, for example, might say, fly 288 degrees, and when you reach distance 12, then turn left and fly at, 270 degrees or whatever. So obviously DME can be used to fly away as well as flying towards, and that's very common in approaches. When we look at the different types of approaches, you'll see it's very often that you will have an NDB stroke DME approach, and you might even have an ILS DME and a VOR DME, depending on the airport. There's a whole load of them. So distance measuring, the concept's dead easy. The idea's dead easy. You just need to tune into the frequency. So remember, if it's co-located with a VOR, then you can just tune into the VOR frequency. If it is co-located with a TACAN, and there probably aren't many near here, I wouldn't have thought the nearest is probably somewhere like Farnborough, Oldham, Vortac. Well, let's try this. Let's see if I can tune nav1, and I will unpause just to see a second. Okay, so you can see here I've just tuned to ODH. ODH is Odium Vortac. So that is a military transmitter used for military bearings. So although I won't be able to use it in my VOR video to navigate with, it will still give me distance, because the equipment they use in a TACAN for distance measuring is exactly the same as the equipment they use in a VOR or anywhere else. So hopefully there's not too much to that. It's not too difficult to understand. You tune in your radio, find the frequency. If you're in X-Plane or Microsoft FSX, you can obviously find the frequency from the map. You can find the frequency from one of these. I've closed it now, PowerPoint. Let's just grab that again. So if you just grab one of these maps a second. So you can find DME frequencies here. So any TACAN, you can use the frequency. If you find a VOR DME, which will look like, not this one, like, no, where's it gone? Sorry, it's under here. If you find a VOR like this, DME, you use that frequency. So find the frequencies dead easy. The terminals work in the same way. You tune them in the same way. The measurement is the same. The only difference with a terminal DME is it only really makes sense in reference to that airport, because that DME could be at one end of the runway or the other. It could even be, you know, a mile to the side of the airport, depending on what exactly is going on. So those only really make accurate sense when you're doing an instrument approach using one of the charts for that airport. But otherwise, like I say, you can use that as a very rough idea if you were getting distance to Cardiff, bearing in mind that Cardiff is obviously surrounded by a massive controlled traffic area, so you obviously can't just fly in there and fly out again. So I want to keep this one short because I think DME is fairly straightforward. Any questions or comments, chuck them on below the video, and in the next video I'm going to look at how we use VORs to actually navigate along certain specific bearings. So thanks very much for listening, and I'll see you